Hello and welcome everyone. I will be with you to begin our lesson. I will finish my experiment right away, and I will be with you. I hope I did not make you wait for a long time. I was trying to capture an image of smallest constituent of matter. Atoms. This drives me to introduce to you our first lesson, matter and element. Let's go to my interactive monitor back there. Matter. What is it? Actually, matter made up everything around us. Matter is anything that has mass and occupies space. State of matter. There are three fundamental states of matter: solid, liquid, and gas. A solid has fixed rigid shape and volume. You can hold a solid, like a rock, it has defined shape. When you put in a box, it cannot take the shape of that box. A liquid has fixed volume but is not rigid in shape, it takes shape of container. If we have a liter of water, the volume of water will not change. Whatever the shape of container I put the liquid water in, it will take the shape of that container. A gas has neither a fixed volume nor a rigid shape, it takes on both the volume and the shape of the container. If we have an amount of a gas, then put it in a cubic container of 1 meter square of volume, the gas will take the shape of cube and volume of 1 meter square. Then we move this amount of gas to spherical container with 2 meters square volume, the gas will take the volume of 2 meters square in shape of the spherical container. The plasma state. Plasma is sometimes referred to as the fourth state of matter, although it is often thought of as a subset of gases, but the two states behave very differently. Like gases, plasmas have no fixed shape or volume, and are less dense than solids or liquids. It contains a significant portion of charged particles, ions and/or electrons. The presence of these charged particles is what primarily sets plasma apart from the other fundamental states of matter. Nearly all the visible matter in the universe exists in the plasma state, occurring predominantly in this form in the Sun and stars and in interplanetary and interstellar space. Matter may exist as pure substance, which can be either element or compound. Mixture of two or more substances. That can be either homogeneous or heterogeneous. After we know what matter is, we need to know what the constituent of matter are. Have you ever built a sandcastle before? What's in this sandcastle? Let's use a magnifying glass. As you can see, billions of very small grains of beach sand, all stacked together to build the castle walls, bridges, and towers. The sand grain itself is built from even much smaller pieces. These pieces are called atoms. They are too small to see. But if you could see them, you would find that these tiny atoms are made up from even smaller pieces. Atom of an element consists of a center part called a nucleus containing protons and neutrons. And outside the nucleus there are even tinier pieces called electrons. Both neutron and a proton have approximately the same mass, of 1 atomic mass unit. Neutrons have no charge, they are electrically neutral and labeled with N and a superscript on the right side with 0. The 0 stands for zero charge. While protons have a positive electrical charge of 1. And labeled P and a superscript on the right side with +1. The 1 stands for 1 charge and the plus sign stand for positive charge. Protons and neutrons are bonded by a very strong nuclear force, and the overall charge of nucleus is positively charged. Electrons have a negative charge which equal magnitude that on proton. Electron labeled with E and a superscript on the right side with -1. The 1 stands for 1 charge and the minus sign stand for negative charge. The mass of an electron is only about 1/2000th the mass of a proton or neutron, so its mass is neglected. In an atom of any element, there are equal numbers of protons and electrons, and so the atom is neutral. Electrons bonded to nucleus by electric force. Two amazing things about the nucleus are: first, the volume of the nucleus is only a tiny fraction of that of the atom. The radius of the nucleus is about 1 femtometer, while the atom itself is about 100,000 times larger than this. Second, nucleus is enormously high density. The tiny nucleus accounts for almost all the atom's mass. If we have a piece of nuclear material about the size of a pea would have a mass of 250 million tons. Although chemists tend to consider the electron, proton, and neutron as the fundamental, or elementary, particles of an atom, but for particle physicists the most fundamental matter is composed of elementary particles known as quarks and leptons. Leptons is the class of elementary particles that includes electrons, while quarks combine into protons and neutrons. We will not talk about that level of fundamental particles for now. Now, did you ask yourself, if all atoms are composed of these same components, why do different atoms have different chemical properties? The answer in the number and the arrangement of the electrons. The atoms of different elements have different numbers of protons and electrons, so this makes chemical elements showing different chemical and physical behavior. Chemical elements are represented by element symbols. Element symbols for chemical elements normally consist of one or two letters from the Latin alphabet and are written with the first letter capitalized. Element symbols have additional details by adding superscripts and subscripts, numbers and symbols. On the left side of element symbol, as you can see, the superscript number represent the mass number of an element and the subscript represent the atomic number. While on the right side of element symbol, more detailed information may be presented, like the ionization state or the number of atoms of an element in a molecule. There are 118 elements known for us, about 20% of them do not exist in nature, or are present only in trace amounts, and are known only because they have been synthetically prepared in the laboratory. Elements react and combine with one or more element to build up a wide variety of substances called compounds. Compound may be one element, like oxygen. Two oxygen atoms form oxygen molecules O2. Or two elements form a compound, like oxygen with carbon forming carbon dioxide CO2. The number of possible compounds is almost infinite. When two or more elements combine to form a compound, they lose their separate identities, and the product has characteristics quite different from those of the constituent elements. For example, pure carbon element is black solid, while in carbon dioxide, it became colorless gas, a new chemical and physical identity. We have reached the end of our lesson. Hope you understand everything I have illustrated. Please do not forget to like the video, subscribe Hatem Science Lab channel, activate the bell to get new lessons and share it to your friends. Thanks for watching.